Maybe I can get it on YouTube for the people who missed, as if they care, but hey. All right, so what did we do? We got our A, B, or C, y-intercept vertex formula. Plugging this in to get the K. Okay, so -1 times -1 is 1. So this, we just have a 2 here. 4 times -1, uh, -9 plus 2, -7. So -7. So our vertex is at, I'll put it up here, -1, -7. Okay. I'll make this one hot pink too. Those are our coordinates. Okay. So what do we need now? Out of the infinite number of points on this graph, okay, and again, we're pretending like we don't know what it looks like yet, but these are the x-intercepts because that's where they cross the x-axis. We'll want to find those, but we're going to pretend like we don't know they're there yet. Well, actually, we would know because we know where the vertex is now, and we know that it opens upwards. So knowing the vertex is here and opens upwards, we know that there will be x-intercepts. We can find this mirror point easily. So because of symmetry, this distance and this distance are the same. The y value here is the same there. So this guy has the same y value. He's down there at -5. And if from here to here is -1, right? Because this is x equals -1. Then we have -1 and then another one. That puts this at -2. So this was called the mirror point, also called the sister point. Oh, other than these two guys, none of the other points have any kind of special name that I could even talk about them. So all that's left now is x-intercepts, and those are the hard ones. The book usually waits until the next chapter before it even introduces them. But before we start looking, if we were just going to use our brain, we know that because of symmetry, let me make this line better. This guy right here. Because of symmetry, we know that this distance and this distance is the same distance, right? So, and we also know that from here to here is -1. Okay. So right here is -1. I'm going to make this like blue. If we just could figure out what this length is, all we need to do is start with -1, and we either add that length or subtract that length. And then we would have our x-intercepts, because what do we know about these guys? We know that the y values are 0 because this is the x-axis. And if you're on the x-axis, you haven't gone up or down. So the y values are 0. Okay. And we could try fancy ways. So here's what we're trying to do is we set our y value equal to 0. Set this whole thing equal to 0. Because remember, what comes out of the function is your y value. And then we try to figure out what the x is. And because x here is squared, this equation has two solutions. So let's go down here and be like, okay, x-intercepts. That's next. Paste. So the y value is this guy, and we want the y value to equal 0, because that's what it is when you're on the x-axis. And this equation, because it's x squared, has two solutions. Now you might get two different solutions. You might get the same solution twice. That's whenever the parabola just touches it. Or you might get imaginary or complex numbers. That's whenever your parabola doesn't even cross it. Now, to solve this, there's different methods. You could try factoring, setting each factor equal to 0. Um, I don't know if I can do that. We could try, but we haven't really studied that yet. What we do know is that the quadratic formula, just in case you forgot, the quadratic uh, formula, it states that if you have a quadratic equation with one variable and you put it in that form where everything is equal to nothing, this equation can be written like this. Negative b plus or minus the square root of b squared minus 4ac, everything divided by 2a. Y'all might like it better like this if I broke it up. Okay. Either way is fine. They're the same equation, but this way we know exactly what x is. And actually, this is two equations, one with the plus and one with the minus. These are the two solutions to this thing. Okay. So we could just use that. So let's try that. So our answers are negative b plus or minus the square root b squared minus 4ac, everything divided by 2a. 2a, 2a. Okay. Now, this part you should recognize from the vertex formula. That gives us our h. That's what gave us this guy right here. That's the minus 1. Minus 1. So I told you if we could figure out that length, we could either add it or subtract it from the minus 1. And we could figure out our x coordinates here. And that's what shows up right here in our formula. So this is minus 1. So we just need to simplify this pile of goop. 4 squared is 16. A minus times a minus is a plus. I'm going to squish this. 20 times 2 is 40. And then bottom, 2 times 2 is 4. Oh, let me insert a new page here. Insert new page. Now, let's keep simplifying. I don't want to cram this in here, so we're going to take more room. We got our minus 1. 40, 56. Now, this is a number. We might be able to simplify it, but I don't think so. The way we try to simplify these is we look, since this is a square root, we need a perfect square in there. Like if I had to remember 12, the 12 has a 4 in it, right? And the square root of 4 is 2, but the 3 gets left behind. But I don't know if we have that with the 56. So let's see what we got. If I don't know if there's a perfect square, I just prime decomposition. I know this is 2 times something. What is it? 2 times 28, right? All right, but 28 is 2 times 14, but 14 is 2 times 7, right? Yeah. 8 times 7, that's 56, right? So, yeah, we can do something with this. So let's go ahead and do that. 2 times 2 times 2 times 7. So if I really just am uncertain how to deal with this, prime decomposition, okay? Because now I can look at it. If I have a duplicate inside, that right there is 2 squared. You see that? So I got minus 1 oops, the square root of 2 squared is 2. So if you have 2 copies of the number on the inside, they come out as a single on the outside. Again, because this is the square root of 2 squared, right? These are inverse operations. Also, this square root symbol, when we get there, that's just another way of writing 1/2 power as an exponent. And later on, you'll learn, if you didn't already know, if you have an exponent to an exponent, they multiply. So 2 times 1/2 is 1. Okay, it's another way to think about it. But anyhow, these two 2's come out as a single 2. And this 2 and the 7, they don't have partners. So they get left inside. And 2 and 7 is 14. So we leave this guy inside. These 2 come out as a singleton outside. 4 is 2 times 2. And now, all right. So this is all arithmetic. 2 over 2 is just 1. So I got -1 plus or minus the square root of 14 over 2. So my two answers are -1 plus the square root of 14 over 2, or -1 minus the square root of 14 over 2. Okay, so this number here, square root of 14 over 2, that we're adding to this, that's this length right here. Boo, 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 square root of 14 over 2, however much that is. If you want to, I mean, you can find out what it is. Square 14 divided by 2. So it's approximately 1.87, just in case you were wondering. So that guy is approximately, what was it, 1.87? I already forgot. Yeah. So these guys are, let's see, -1 plus that, -1 plus that, 0.87, and -1 minus that, -2.87. So that's what the values approximately are. If I start with the -1 and I add or subtract this guy, okay, which kind of makes sense. This is a little less than 1, pretty close to -3, right? So, uh, okay, so what are we doing here? Yeah, this distance. So, let's, we're going to write exact. We have -1 plus the square root of 14 over 2. Now this guy is -1 minus the square root of 14 over 2, right? Those are our x-intercepts there. I guess I don't need that. Let's just put this right next to it. Now, check out our picture. We have our axis of symmetry, and the equation for it. Every single point on this line has an x equals -1 that we got from the vertex formula. H equals -b over 2a. H is the name we give to the x coordinate of the vertex. So once you have the x, the function will tell you the y. Take your x, give it to the function, it takes that and it spits out the y value, boom, which we did right here. Boop. Once we had the vertex, we knew it opened upward because the a value was positive, so that meant it went like that. That told us there had to be x-intercepts, so we had to look for those. Of course, we want the y-intercept, but that's easy to find because on the y-axis, x is 0. You just plug 0 in for x, and you're left with the c value. Boop. All right. For the x-intercepts, we just had to set the y value to 0. This is the y value, so we set it equal to 0 and solve for x. And the quadratic formula, this guy always tells us the answers. So we used it. We just plugged in our a, b, and our c. And we weren't surprised to see this guy show up, because that is straight from our vertex formula, this first little piece. That guy. Boop. And then we figured out that little bit. And now we have our whole thing here. Come on. Y'all got any questions? Okay. Well, so that was as thorough as I can be, and we want to move on soon to the next stage. I need to give y'all a quiz though. So the next stage will be, I'll give you a graph and you figure out the function. I think that's what we need to do. I'll check the book and see if they want us to do that or not. All right, daily quiz number 20. Today is, what is it, National Indigenous Peoples Day. So if y'all can think of an idea where we can incorporate the holiday into our math, let me know. Let me give y'all one to graph here. All right, we need an X, a Y, and an A, B, and a C. I'll do a -2 +1 -3. There you go. Y'all can graph that. I will put it in the Desmos for you. -2, 1, minus. Oh, dang it. Hold on, I might change it. -2, 1, -3. Yeah, that one doesn't have x-intercept, so I want to make sure it does. Let me try a +3. Yeah, we'll do that one then. Just change this to a positive. Yeah, there we go. And I'll take a snapshot. So kind of pretend like you don't have this picture to look at for reference. Let's go ahead and label everything that's missing. Some teachers are real sticklers. They always want you to label the x-axis and the y-axis, just for starter. All right. So I'll give you all a couple of minutes to do this. When I come back, remind me to hit record, because I'm going to pause the recording. Oops. No, that was the screen sharing. How do I pause recording? Oh, resume recording. Okay. So we have a parabola here, right? Boop. I figure the concept of a parabola probably isn't too bad for y'all. It's just this weird U shape, right? Yeah, it's defined by a function, right? So you have inputs, and the whole thing is the output, and that's what makes this shape. Okay, so the anatomy isn't too hard. There's a thing called a vertex, and it either opens up or down, and then it might cross your two axi. Okay, not too complicated. I figured the hard part for y'all is probably just the arithmetic. But we have this nice little list of steps. First, let's get our A and our B and our C. Now the A is negative, so that tells us it opens downwards, which fits our picture that we're not supposed to have. Okay, but okay, great. Now what? Well, the easiest thing to find next is where it crosses the x-axis, because I'm sorry, not the x-axis, the y-axis. This dude right here is called our y-intercept. The one thing we already know half the information about it. Because if
I
you're right
think your
here,
screen is frozen.
my screen is frozen. Dang it. Okay. All right, hold on. Oh, let's try it. There. How about now? Is it working now?
No.
Doesn't look like it.
No? Okay. So I'm writing on the screen here. All right, let's try uh this button. Anything? No?
No, nothing.
All right, let's try uh entire screen. All right, I'm gonna try that. What does it say here? Oh, wait. Screen sharing is paused. All right. Unpause. Unpause. All right, I'm gonna stop it and try again. Shit. Ooh, I think it might be working this time. Any luck?
Yeah, it's working.
All right, sweet. Okay. So yeah, concept's pretty simple. It's a parabola. It has a vertex and it has a y-axis, a y-intercept, and sometimes it has x-intercepts. That's it, right? The hard part's the arithmetic, really. Here's our function. The x's tell us the left and right. The whole thing tells us the up and down for every coordinate. Um, Here's our a, b, and our c, -2, 1, and 3. A is negative, right? Yeah. So that means it opens downwards. And that agrees with our picture. So the easiest thing to find now, since it's in what we call general form, is where it crosses the y-axis, this guy, the y-intercept, because we already have half the information. If you're on this line, then you have not gone right or left. That means your x is 0. And you can just look at this guy, all right, and see what it is. So the y-intercept, if x is 0, that's 0, that's 0, you just get 3. So since when you plug in a 0, 3 is your output, the y-intercept is 0, 3. That means this distance is 3. So 0, 3. Boom. All right.
Where'd you get that? Okay.
Yeah. So right here.
Okay.
Yeah. Every point right here on this y-axis, x is equal to 0, right? Because we haven't gone to the right or to the left. Make sense? All right. If you are here, well, here's your origin, right? I should put this right here. Boom. That's the origin. This is 0, 0. So x is to the right or to the left, and then your y is up or down. So if I'm anywhere right here on this line called the y-axis, my x is always 0 there. Everywhere here, x is 0. Okay? Since the y-intercept is on the y-axis, I know the x is 0. And the function, its job is to turn x's into y's. So plug a number in, replace the x. This whole thing is the y value. So when I plug 0 into the function, you can see it because, like, if I replace x with 0, 0 squared is 0 times anything is 0, plus 0. So when
Mhm.
x is 0, this is the only thing that's left, the 3. So one of the coordinates on the graph is 0, 3, and it's the y-intercept. Does that make sense? Okay. Kind of likewise over here on the x-axis, our x-intercepts, if we're right here, this is where the y value is 0. Because right here, you haven't gone up or down. So for these guys, their y values are 0. And we'll use that to figure out what the x is, whatever that is, the left and right. Okay, we'll do that when we get there. First, we want to find this guy, the vertex, next. Um, so luckily we have a formula. Vertex. And remember, we like to use the letters H and K to talk about this guy. It's so important the coordinate has its own name. And the H here is always given by negative b over 2a. So if you're stuck with it in general form, you kind of have to use this. We have a minus sign. The b is 1, right? B is 1. Then we have a 2, and then the a is minus 2. So now we just simplify this fraction. A minus and a minus cancel. 2 times 2 is 4. So this coordinate right here, we know the x value is 1/4. So I'm going to go ahead and do this little do 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 do. The x value here is 1/4. Every single point on this dotted line has an x value of 1/4. Okay. This dotted line is called the axis of symmetry. Why? Because if you fold this guy over this line, it will match up. Fold it in half and it matches. That's called symmetry. So that line, since every x on there has 1/4 for its value, the y values, pick any y you want. The y's go from negative infinity to positive infinity. Y can be anything, but the x's are always this number. So that's why this is the equation, this line. That looks kind of weird. 1/4. There we go. So once you have your x coordinate, also they like to call it h for the vertex, you know the axis of symmetry. So pretending like we don't have this graph, we would know that our vertex is somewhere on this blue line. What we need to find out is the y value. So we need to figure out the y value there. Well, that's what the function does. If you give it an x, boop, boop, it'll tell you the y. So to get the y value for that vertex, all right, the y value, they like to call it k, all right, you just plug in whatever you got up here into the function. So let's plug that in for a function. Now is the hard part. This is the arithmetic. I got a minus 2 times my input squared plus my input plus 3. Okay, so now this is just fraction work. Since we're going to have to add them, let's plan ahead. We know we're going to need common denominators. Let's see, I got a minus 2. 1 squared is 1. 4 squared is 16, which I'm going to write as 2 times 8. Since I got a 2 up here, I want to simplify them. Okay, so that's that guy. 16 And a 2 over 2 is just 1. So I can cancel those out. Now I got a fourth, but this guy is an 8 on the bottom. So this 1/4, so that I'll have an 8, I'm going to hit it with the number 1, multiplying by 1. So I have a common denominator. And then this plus 3, he didn't have an 8 on the bottom. So I'm going to give him an 8 by multiplying by the number 1. So everything has 8 on the bottom. What do I have? Minus 2 plus 2 plus 24. Plus 2 minus 2 cancels. 24 over 8 is 3. So that's the y value for my vertex, 3. Boop, which you can see it right here, but, well, no, wait a minute, that's not right.
I don't think so.
No, that's where our y-intercept was, right? See, when x is 0, you get 3. We didn't plug 0 in, we plugged 1/4. All right, so I did something wrong. All right, the key to being a good mathematician is the same as the key to being able to write essays. Rethinking every thought you have as you write, because nobody likes to do 8 rough drafts. Let's check. We have a minus and a 2. My input squared. Aha. Nope. Plus my input plus 3. That looks good. Let's see if y'all can catch my mistake before I do. Got the minus 2.
Mhm.
1, 4 squared is 16. Looks good.
Wait a minute. If you're at 16 there, then why did you end up at 24 over there?
The red, the what? Where? Let's see. That's a fourth. This is the number 1. Whoa. That's 3. This is the number 1.
So what did you?
Something ain't jiving here. 4 times 4 is 16, right? Yeah. No.
Mm-hmm.
That's there. That's 1. This is 1. Right. Minus plus plus. All right. Sure. Huh. My brain's not braining today. So we have a oh, right here it is. We canceled those 2's, right? See, that's where it is. Boop. Should be more clear about that, right? My little
Okay.
crossed
So
out.
that's
Yeah, it should be a -1. There it is.
so
Came from bad handwriting, basically, right? Okay, so 24 minus 1 is 23.
it's 27. No, wait. Minus one.
Yeah, this one's negative. The first one is negative. So it's 26 or try that. 26 minus 1 is 25. There we go. 24, 25,
Okay, what are
26.
you, 24 to 5%? Okay, so now, okay. So this should be 3 and 1/8.
That's
Is that
right.
correct?
So how many times will 8 go into 25? Well, it'll go into 24, right? 3 times, right? So There's 24 plus 1 is 25, right? So this plus that. So we got two fractions here. The one on the left, 8 over 8 is just 1, so we're left with the 3. And then the 1/8. Let's y'all write
Okay.
it like this. 3 and 1/8. That's how y'all like to write it. I like it like this. Because if you're going to do something with this value, the first thing you have to do is turn it into that. That's why mathematicians always leave it like this, because that's how it has to be if you're going to do something with it, right?
But so we're not mathematicians.
Right? Y'all are like, we don't do anything with numbers. We just want them easy to look at, right? I'm like, nobody ever gives me a number unless they want me to do something with it. All right, so 3 and 1/8, however you like it. Since we're gonna have to do stuff with it, let's leave it like this. All right. At least this is a number that shows up on a tape measure. 25 over 8. So uh that is not 3 because it's higher than 3. It is 25 over 8, which is 3 and 1/8. Okay. Now, now that we know that point, if you want to, you can get the little sister point or mirror point for this y intercept. Okay. We know they have the same y value, the same height. From here to here is 3. And we know, let's see, that this distance is the same as this distance. Okay. And we know that from here to here is 1/4. So if we go a fourth and another fourth, 2/4,
That's 1/2.
that's 1/2. That's right. There you go. Okay. So that's our little sister point. Actually, it'd probably be better if I put this one over here. Boop. And this guy didn't have to be across the world, right? There. Boop. There. There we go. So we got the vertex, we got the axis of symmetry, we got the y-intercept, we got its sister point. The only other thing to know is x-intercepts. And we know it has to have them because the vertex was up here and it opened downwards. That tells us right away we're going to have x-intercepts. Okay. So we know if we're here that the y values have to be 0. And this is the y value. Plug in an x, this is the y. So what we need to do is set our y equal to 0 and then solve for x. Now, luckily, we already have the answers because the quadratic formula gives them to us. So we're going to need more paper to find the x-intercepts. Take your y value, set it equal to 0, and solve. Now, there are other methods other than quadratic formula, right? If I had something like this instead, I wouldn't use the quadratic formula. I'd look at that and I'd know I could factor this. To get an x squared, the only thing that works was an x and an x. X times x is them. And to get a positive 1, the only thing that would work is a 1 and a 1, or a -1 and a -1. That times that gives me that, and this times this gives me that. But I have to get these, what they call the cross terms. So I know it has to be this because I will get an x times a 1 and an x times a 1. When you add those together, I would get that. So if I had this instead, I would factor this guy to be that. And now I could use the zero factor property. You see, this is a number and that's a different number. So if I have two numbers that are multiplied and they're zero, one of these numbers has to be zero because zero times anything is zero, right? Then I could set each factor equal to zero. So instead of having a second degree equation with two solutions, I can have two first degree equations. But here, this one's hard. This It's easy if there's just nothing in front of the x squared. So this is harder. So let's just go ahead and use our power tool, our quadratic formula. So the answers to this equation are always negative b plus or minus the square root b squared minus 4ac and everything divided by 2a. Now, as a mathematician, I'd be like, there's the answers, right? But most people like their answers simplified. And the rest of this is not algebra, it's just arithmetic. So, arithmetic's pretty hard if you don't practice it all the time. There's only a handful of rules. I mean, we literally start as children looking at our fingers, and that's how we learn how to add. And multiplication is just repetitive addition. All right. And roots, they're simple. What does a root mean? Either I give you the area of a square, and then we call the length of the side the root, right? Or an exponent, I give you the length of the side, I'll call it r for root, and the area be square the length of the side. So that's where exponents came from. So if you build up all the ideas behind this arithmetic, starting with looking at your fingers, the concepts are easy. It's just the notation that's cumbersome. We've already done this. That's our negative b over 2a. But anyhow, two minuses cancel and a 4 on the bottom. See, we already knew that was going to be 1/4 because of symmetry. X equals 1/4 right here. That's 1/4. So what we're really finding is this little length right here. We're going to start at 1/4 and either add or subtract that little bit. And that little bit is this ugly guy. So let's do the arithmetic. 1 squared is 1. A minus times a minus is a plus. 4 times 2 is 8. 8 times 3 is 24. And when I do these, I always like to put the top and I like to put a little lip over here where it ends, so nothing gets left out. 2 times minus 2 is a minus 4. Now, this minus sign, you're going to see that we can throw it away. Why? Because plus or minus could have just as easily been written minus plus. These are two separate equations, and their order does not matter. We just want the two answers. But if you want a positive, so this equation, a positive times a negative is a negative. And then the other equation, a negative times a negative is a positive. All right, so I dealt with the minus here. All it did was flip our switches. 1 and 24 is 25. And the order doesn't matter. It just looks silly writing minus plus. We always write it like that. That's why effectively we could just throw that minus away down there. The square root of 25 is a nice, easy 5. We got common denominators. Boom. 1 plus 5 and 1 minus 5. Sorry about that. Okay. And also over 4. So these simplify. Uh, 6 is 2 times 3. 2 over 2 is 1. Over here, this is minus 1. So 3 halves and minus 1. So that little bit was 5/4. So our x-intercepts are they are coordinates. The y values are 0, right? Because if you're here, y is 0. And now we know these values. We start here and we add 5/4 or subtract 5/4. So 1/4 plus 5/4. What are they? Minus 1 and 3 halves. Those are the x-intercepts. Minus 1 and 3 halves. There we go. So again, we learned that this distance was 5/4. And we added it to the 1/4. All right. That's the full anatomy of a parabola. Now I know this is a lot. I mean, college algebra, this is really 3 years of math because in K-12 you take pre-algebra, algebra 1, and then algebra 2. So we're taking 3 years of math and doing it in 4 months. And this 4 months of math is thousands of years of math, you know? That's a lot. But the only thing that makes it doable is because it's been refined so much. The notation has been refined to make it as easy as possible. If there's a way to make this easier to learn or understand or use, we're hard pressed to see how, you know. The only thing we could do to make it easier to learn is use our tools like Desmos to do the graphs and things like this. Imagine learning about this without an XY coordinate system, right? Technically, this stuff without the f of x, just this equals stuff, that would be algebra. And then geometry is the pictures of things without the XY coordinate system. Once they did the XY coordinate system and they figured out how to come up with functions where you could draw the picture, this kind of called algebraic geometry. Putting the two together is real where the real power is. All right, any questions? I think that's all we have time for today. Let's take a quick peek, see where we left off. I don't know if I want to make y'all graph another one. Graphing. What did we look at in the book? Nothing. Okay. Let's take a quick peek in the book. And I know y'all can do this. Y'all know the steps. Knowing how becomes being able to do it just by practice. Oh, yeah, word problems. That's what y'all need to be able to do. So, yeah, next time we'll do word problems. So, this will be your exam, page 128. Wait a minute, is this one where they actually give you what you need? Yeah, okay. They have like a whole chapter where they have word problems, but they don't want you to do them. They just want you to read it. They're more like reading comprehension problems. All right, so I'll talk about this a little bit so that you're not just. When I was in school as a kiddo taking this stuff, I could usually do the basic math problems, but the word problems I could never do because I didn't really have any comprehension. I could just look at the examples and follow an example. I could follow instructions. That's all I could do, really. How am I going to fit all that on there? Okay. Does that fit? Not really. I guess y'all can maybe read that. So most of the time, the simple fact is that gravity makes things fall, right? And whatever the height is, we call this height. So this is a height function. Now, unfortunately, we already used the letter H for the vertex, but we want to talk about height. So we're going to reuse that letter H. So here, instead of f of x being our y, all right, this is going to be h of t. Dang it. So t is the name of our input because it's time, and the h is the name of the function. And we'll even use it for the name of the output if you wanted to, height. Now, the time it takes for an object to fall and hit the ground is a parabola. Now, I know that this kind of looks like the trajectory of like a ball if you threw it, but one thing you need to understand very clearly is all this says is height. It has nothing to do with any kind of horizontal motion. Okay. So if I threw a ball straight up and straight back down, or I threw it this way, it doesn't matter. This has nothing to do with horizontal motion, right? If you shoot a bullet sideways, the time it takes to hit the ground is the same as the amount of time as if you just dropped it. So all this does is tell you the height at a given time. And now notice the A is negative. That means the parabola opens downwards, which is what you would expect. Something that goes up has to come back down. Okay. So if you throw something up and it comes back down, it'll reach a peak height. So that's how you find the vertex, and that's how you know it's the highest point. You'll see how high it went. You'll know when it reached its highest point. All right. Um, so find the vertex for that guy, and y'all know how to find vertexes. Um, this is a model of reality. So negative numbers don't apply, and a height that's negative does not apply. Okay. And oh, that's what I forgot to talk to you about. These two examples, real quick. The domains and ranges. The domain is how far left and right this thing goes. It goes forever to the right and the left. So you can always just say all real numbers. The range is all the outputs or all the y values. The lowest this thing goes is a -7, and then it goes up forever. So since that's the lowest it goes, the range here is -7 and then up to infinity with a square bracket, because -7 is a number that comes out of the function. Because if you plug in whatever the excess is, you get a -7. So that's the range. And since this is the lowest this thing goes, -7 would be called its minimum value. And our dude here, again, the domain, all real numbers. This guy, its range, the highest it goes is 25 and an eighth. So anything from negative infinity all the way up is 25 eighths with a square bracket. And since that's the highest it goes, this is called its maximum. Okay. Now, here we don't want range being negative. So we're restricting our range. That's our range. And we're restricting our domain. That's our domain. Okay. So just keep that in mind. You can see the height 6 seconds after it's launched. just plug 6 into the time and make sure it matches because it says T has to be in seconds and H will be in feet. So make sure they're giving you the time in seconds. Otherwise, you have to do the conversion. So these, they're giving you a time and you're finding the height. Here, you're finding if it's going up or down. Same thing here. Plug in the 6 and you'll be able to tell from the picture if it's going up or down. When is it this high? Well, that's you set this equal, set the height equal to 112 feet, and then you have to solve for the time. To do that, I'm going to give you a tip here for that guy. You're setting the height equal to 112 feet. How do you solve this? Use the quadratic formula. You want to rewrite it and put it into standard form. Subtract 112 from both sides. Now you have a quadratic equals 0. Here's your A, your B, and your C, right? If you know your A, B, and your C, plug them into your quadratic formula. I recommend factoring out the 16 first. How many times does 16 go into 128? So 128 divided by 16, 8. And then 112, 7. So this guy, this times this gives you that, this times this gives you that, and this times this gives you that. And then divide both sides by this thing. So now you have smaller A's and B's and C's. So this equation is the same as this one. I just divided everything. So now you can have your A, your B, and your C. Use the quadratic formula. And then I'll let y'all figure out these others. And I'm out of time. So thank you for waiting. Y'all. Oh, I forgot to write daily exam here. Daily exam number 20. So next time we'll do more word problems and then we'll move on to looking at graphs and figuring out the function. Any questions, y'all? All right. Cool. I'll catch y'all next time. Bye, everybody.
Hi, sir.